In this one, I want to show you 4 different ways to represent a one-to-one or injective function. Now what you see here is we have a one-to-one function represented in what I call a bubble diagram. It's called a bubble diagram because these look like bubbles here. And this function is in fact one-to-one. Now you might say, how do we know for sure that it's one-to-one? Okay, now what we could do is we could label these x1, x2, x3, x4, and then we could check. We could check our definition of one-to-one. Remember, there's a defining property for one-to-one. That is, if xi does not equal xj, then f of xi does not equal f of xj. And remember, this has to be true for all xi, xj. All right, so what that's saying is that if any two of the xi's are not equal, so here you see that x1 and x2, otherwise known as 1 and 2, are not equal, and their function values are different as well. Their function values are not equal as well. They go to different things. So everything goes to its own thing, right? Every input has every output has one and only one input coming over to it. That's one-to-one. Every output, and the outputs are 5, 6, 7, and 8, right? 9's not an output, that's just an element of the target or codomain. But every output, 5, 6, 7, and 8, has exactly one input coming over to it. And that's really what this statement here says. And the for all puts it all together. All right, so now let's look at the many different ways that we could represent this thing. Right, I'm going to get rid of the x1, x2, x3, x4 because we don't really, we don't need those. Right, so here's a bubble diagram. We could represent this in a table. We could represent this as x, f of x, and I'll draw a vertical table. You could easily turn this on its side and make a horizontal table. All right, so you got 1, 2, 3, 4. And let's see, what is 1? 1 goes to 6, 2 goes to 5, 3 goes to 8, and 4 goes to 7. Now you see we have, in fact, represented it with a table. So notice these give you all exactly the same information. 1 goes to 6, 2 goes to 5, 3 goes to 8, 4 goes to 7. We could represent this as a set of ordered pairs. One goes to 6, 2 goes to 5, 3 goes to 8, and 4 goes to 7. Now, remember before when I showed you that formula in the blue box is somewhat complicated to check, right? So let's try and think about what it is. How can we tell that something is one-to-one without having to check that, that formula every time? Well, let's see. In our table, look at what happens with all of the f of x values. All the f of x values are different. That's key. That's required to be that way. Now let's see how that would change, right? So let me make this function so that it's not one-to-one for just a short time. If I made this function not one-to-one, let's say I took 2 and put them over to 6, then see what would happen here? Then right here, we'd have a 6, and they wouldn't all be different. They wouldn't all be different, right? Notice how this would transfer over into our to our set of ordered pairs. Right? Do you see what's going on? So as soon as we make something not one-to-one, then there's repeats. Repeats here. If you have any repeats in your f of x column, then it's not one-to-one. That's it. It's easy. It's that easy. And if you write it in a set of ordered pairs, if you have any repeats in your second coordinates, which is really just what this second column is here, it's just second coordinates, right? If you have any repeats there, then it's not one-to-one. Okay, so now let's make it so there's no repeats, right? That was a 5. No repeats. Well, if that's a 5, then that makes that a 5, and we have no repeats. And what does that do over here? Puts 2 up to 5, and now it's one-to-one again. So these are all different ways of representing one-to-one. And now let's look at the last way. The last way is with a graph. Let's see, 1 goes to 6, 2 goes to 5, 3 goes to 8, and 4 goes to 7. Now remember what happened before when we made a repeat, right? We made everything go to, we made 2 also go to 6, right? So let's make some repeats. Let's make some repeats. What we'll do for that is we'll make that a 6. Now what happens with our, so 2 now goes to 6. You see what's happening there? It doesn't pass the horizontal line test. So with the graph, how do you tell with the graph? It's the horizontal line test. You've probably seen that one before. Well, the horizontal line test is really the same as just saying there's no repeat. If it doesn't pass the horizontal line test, like here, it's not one-to-one. That's the same as saying there are repeats in the second coordinates of our list of ordered pairs. All right, let's go back now and make this back into a 5. And so now 2 goes to 5. One-to-one, no repeats. And okay, so passes horizontal line test. So if it passes the horizontal line test on the graph, that's the same as saying that when you write it as a list of ordered pairs, there's no repeats in the second coordinates. Is the same as when you write it as a table, there's no repeats in the second column, is the same as one-to-one, just satisfying the definition. Now there's one catch here, and that one catch is if you write your set with a repeated, let's say I put 1, 6 in there. Remember, as a set, repeats are counted as 1, so it still works, but you might see repeats because you wrote the same thing twice. And that's 4 ways to represent a one-to-one or injective function.